So the last part of this section is about a deck of cards. I know some of you are familiar with cards and some of you aren't. So I wanted to break it out here and get a picture for you. When you have a deck of cards, there's 52 cards. 26 of those are black. 26 of them are red. So let's write these things down. 26 black, 26 red. You have 4 suits. The 4 suits that you have are spades, which is this first one right here. Hearts, which is this one on the bottom left. Diamonds, the one on the bottom right. Clubs, the one on the top right. Each of those 4 suits has 13 cards, the numbers 2 through 10. They have a jack, a queen, a king, and an ace. Here I want you to note that an ace really does count as a 1. But it doesn't matter if ace is high or low. That's not what we're worried about in this class. We're going to be looking at probabilities, so we just need to know how many cards there are. I do also want to point out that each deck has 3 face cards. So what's a face card? A face card is a jack, queen, or a king. Because if you look at the deck of the cards, there is actually a face on a picture of a face on those cards. So in total, you would have what would it be? 3, 6, 9, 12 face cards total. So let me write that down. 12 face cards. Okay. I'm trying to think what else. There's probably some other things, but that should be enough to get through here. Okay, so it says from a standard deck of playing cards, 5 cards are to be chosen. How many 5-card combinations contain the following? Well, if 5 cards are chosen, a 5-card deck, this means that order does not matter. There's no order. It's either in your hand or it's not in your hand. So since order doesn't matter, we're going to be using combinations. Okay, let's look at the first one. The first one says 2 kings and 3 queens. Anytime we want to break it up like this and they're asking for something specific, we want to consider each one of those things individually. So here, for instance, I'm going to look at the kings first, and then I'll look at the queens second. Again, order doesn't matter here, so I don't have to multiply times 2 like I did with the people sitting in the chairs. So, a deck of cards has 4 kings. Of those 4 kings, I want 2. A deck of cards has 4 queens. Of those 4 queens, I want 3. I do want you to notice here the amount of cards that I get, the total number of cards that I get, which is 2 from the first, 3 from the second. When those add up, that needs to be the 5 total cards that I wanted. You always need that number to add up to be 5. Okay, so go in your calculator and go ahead and do 4 choose 2 times 4 choose 3. Let's see what you get. Looks like I'm getting a total of 24 possible ways of being dealt 2 kings and 3 queens. Distinct possible ways. How about 5 hearts? So 5 hearts, the only thing I want is hearts. I don't need to consider multiple things. So how many hearts are there? There's 13 hearts in a deck of cards. Of the 13 hearts, I want 5 of them. Again, order doesn't matter. It doesn't matter which order they came into my hand, so I'm using combinations. Plug that into your calculator now and see what you get. I'm getting 1,287 distinct possible ways. What about 5 cards of the same suit? Well, didn't we really kind of just do that? 5 hearts is 5 cards of the same suit. So when I got that for one suit, I had a total of 1,287 different ways. But how many suits are there? Well, there's 4 suits, so all I have to do is multiply that times 4. If I multiply that times 4, looks like I'm going to get 5,148 total different ways that I could get 5 cards of the same suit. For those of you who play poker, that's called a flush. All right. So let's look at the next problem, see if we can answer it. It says 5 cards are chosen from a standard deck of playing cards. How many 5-card combinations contain 4 cards of the same suit? So this one's a little more difficult. So here we need them of the same suit. And then, let's think about it. We need 4 cards of the same suit, but this is a 5-card deck, or I'm drawing 5 cards, so I have one that's not the same suit. So what I don't like about this problem is where it says how many combinations contain 4, it really should say exactly 4, because we have to presume that that 5th card is going to be a different suit. Okay, so let's consider this. We have 13 cards in one suit. Of those suits, we want 4. How many cards do we have remaining? We have, well, let's see here. We had 52 cards. We removed 13 cards from the suit. That would leave me with 39 cards that are not the same suit. And we have to presume that 5th card is not the same suit. So if that 5th card's not the same suit, there's 39 cards to choose from, and of those I choose 1. Again, I want to emphasize, going back to what I said earlier, is that when you add those numbers together, it better be the total number 5 for the cards of suits. A lot of people would just do 13 choose 4 like they did in the previous problem, but that does not work. You have to pick that one card that's not. Okay, so when I do this, it seems to me like I'm getting... Give me 1 second and let me put that in my calculator. I'm getting 27,885 ways of choosing 13 cards, 4 cards from one suit and 1 card that's not from that suit. But this would be if the suit was, for instance, hearts. So how could I do it if it were spades and then clubs and then any of the other suits? It seems to me like we should take that number and multiply it times 4. When we multiply that number times 4, I'm getting a total of 111,540 distinct ways of getting 4 cards from one suit and 1 card that's not from the same suit. So exactly 4 cards of one suit. So my answer is 111,540.